Hi, this is Kunal here. I'm the co-founder of Hexo AI. We're trying to build AI that can build AI. Our hypothesis is that if we want to get to super intelligence, AI must be able to build new forms of intelligence and to be able to also create itself and a better version of itself. So this is our uh, V1 of it. We're working with some companies to help them build their AI models. So I'll actually give you a quick demo of how our platform works. This is the overall home page and projects page. You can go ahead and create a new project. So, for example, if I want to create a face quality detection model, I can go ahead and create a project. So here I can actually just open a new project. How this works is I can set up a project configuration, which is basically like it is basically the prompt for the agent. Here I can enter a task description. So in this case, what we do is I'm going to be entering a task description that's very Kaggle style because that's what we figured becomes a better way to prompt our model. So I've just pasted a prompt here. So I'll actually just run you through it. It's basically image quality scoring. This data set contains images that need to be classified based on their quality into two categories, good and poor. The task is to develop a machine learning model that can accurately predict the quality of images and provide probability scores for the good class. Then it also mentions what's the data set structure. So we have a training data set which has good and poor images. We have a test data set. And here's a split of how the data is available and what's the data format. There's some additional information. We have submission format and we have what kind of evaluation. So the competition will evaluate submissions based on the probability scores. So the metric is an F1 score. So we're trying to get an F1 score on this. So some general notes, right? Like here we said, we use PyTorch and not TensorFlow. So what could be our stopping criteria? We could just say that, when the F1 score hits 0.95, for example, right? So here I want to specifically train a model, and I also have options of using pre-trained models. So I could just click on that if I want to use that approach. So as I mentioned, we can also train models as well as build new pipelines. And here I'm going to just drop all my data files. So all of these data sets come here. I can just check them. And yeah, I think so. I'm going to just put some execution limits like, run for 100 steps or just spend only $5, for example, right? And I save this, and that's it. That's all I need to do to get started. I've actually created my overall project configuration, and now all I need to do is actually just hit build AI, and now my agent has started executing, and now I can just pretty much sit back, and when I come back, I'll have my model ready. It may take a few minutes to execute because training a model takes a bit of time. Uh, that's basically dependent on how long the GPU iterations etc. run. So yeah, and this will kind of start working. Meanwhile, while this agent is running, I'll just show you a previous project where I ran something similar. It's the exact same project. In fact, I ran it earlier just so I can show you what the agent did. As you can see, the task is exactly the same. I can actually go and see what are the models that it trained. So I actually have a final version here. I'll also show you what the agent steps it took. So this is a very weights and biases kind of a view where you can see what runs it created and what was the score. So in this case, it got a 0.97 F1 score. In this run, it got a 0.988. So if I click on this, I get details of it, that it used the efficient net B0 model with transfer learning and fine tuning, uh, key improvements from the previous model, right? So when it created the previous one, it used a ResNet 50 model, and these are all the configurations it used. And at the end of it, the agent also suggested some improvements, and it said use an efficient net B0 as a base model, implement more extensive data augmentation to improve model robustness, use a weighted loss function, and that's what it actually did in the next one, right? uh, we can actually we look at what did the agent actually do in the back, right? You can see that in the first step, it actually just initializes the entire thing. Then this is all the agent steps. So here's my prompt, which I gave on the right side, and I can actually look at what the agent does. So it says I need to check my current directory structure and files to understand what we're working with. I need to create the models and output directories which will be used to store our trained models. I need to examine the data directory. I need to check the format of the sample submission. So each step is recorded here. I want to check some examples of poor class images. I need to create directories to extract the training. And so it kind of sets up an environment. It creates all the folders. It writes scripts as well, right? So if I just keep scrolling down, here's something interesting. So it says I need to check if PyTorch is already installed in the environment as we'll need it for our deep learning model. You can actually see the action it took, which is the code it ran. Uh, and the observation is that, okay, you see a warning package not found torch. So it hit a bug, right? It hit an error. And what it does is it actually debugs itself and solves the error as well. So in the next step, it says I need to install PyTorch and other necessary libraries because the previous one, it hit this error, right? So it actually goes into a loop trying to solve things. And then once it's done that, then it says that, okay, creating the training script for image quality classification model, the script will handle data loading and preparation. And it also says model saving and metrics calculation, early stopping based on F1 score, creating a new file inference.py. So it kind of goes into this, and then it says now I will run the training script to train our ResNet 50 model, right? And again, it hit an error, and in this case, the error was source not found. So it says let me try with something instead, and it keeps trying, and then it says okay, in this error, I think it hit. Yeah, it kind of hit some error, and then it says I need to fix the scheduler initialization. So it seemed to have worked, and it went ahead and edited the train.py file, and yeah, it actually went ahead and trained this model for 10 epochs. You can see this. It ran the script. Here we have the observation. So there's a in each epoch there was a training loss, which kept getting better. And then finally it says, okay, I've reached a best validation F1 score of 0.99. Yeah, so it was kind of able to, yeah, you can see all of this in the observation of what it really did in each step, right? And then once it actually trained this model, because there are some steps remaining, it just went ahead and said, okay, here are some ways I could further improve it. So it went ahead and actually improved what it did earlier. And this time it says it's editing the training script to use efficient net model. So it kind of keeps going in loops to keep getting better and better, because how we've built this engine is to optimize for evaluation. So everything the agent does is trying to move towards a better evaluation. So it kind of keeps going there. So we can actually go and try out this model as well. What we have is also a small app generator here. So it's sort of like a front end generation agent that uh, can generate a simple front end for us to test out the app that the model that we've built. So based on what is the model and the our objective, it generates a front end that's specific to it. Right now, it generates a Streamlit front end. So here I can just upload an image, for example, and ask it to predict what the quality of that image is. Right. So I'm just uploading this image, and it has actually predicted that the image is classified as poor quality. So you can see the model works. Uh, and because it's CCTV footage data, I can just maybe upload one good quality image, which is by CCTV image quality standards. This would be classified as a good image. Yeah, it's classified it as a good image, right? Because you can see the face in it. So as you can see, the model works, and you can also get access to all the files that have been created. You should be able to see that here. So you can actually access all the training scripts, the eval scripts, the inference scripts. Everything is available here for you to also use once you've trained a model, right? So yeah, it kind of generates the scripts. It generates an app for you to try out as well. Now I'll actually just go back to the project which we had initiated at the beginning of this video. Yeah, here you can actually probably see that the agent has started functioning. So when we had left it for the previous project to go and see the previous project, the agent hadn't started, but now by the time we are back, it's already created 18 steps. Right now it's on the 18th step, so it's actually working. I'm going to just pause this agent for now, so we can go back. So yeah, this is what our agent does. It trains models by itself, and it can also write pipelines based on trained models. We do have some samples of that as well, and what I'll do is I'll share a separate video for that. Thank you.